Oh, right away. Hit my knee. All right, let's see. I don't remember which section, maybe 4.2, where we talked about the unit circle, but we haven't actually really used the unit circle at all. So I wanted to go over using the unit circle. The majority of us have answered like sine, cosine, tangent by just drawing triangles or remembering the value.
I was asking about the whole return. I'm sorry.
That's okay. I just want to make sure that you didn't miss anything. Okay, so the formulas for like sine of theta is what? Sine is, so it's y over r, except we're going to be talking about the unit circle. So on the unit circle, it's r. 1, because the unit circle means r is 1 unit, 1. So any place that I say r, we're not going to write 1 because y over 1 is still just y. So on the unit circle, the sine of theta is the y. On the unit circle, the cosine of theta is anybody? X, because it's x over r, and r is 1, so it's x. And then the tangent of theta, it's still y over x. Nothing changes for a tangent because tangent doesn't have an r. And then the other 3 trigonometric ratios, we just flip the first 3. We just reciprocate them. So 1 over y. Secant would be 1 over x. And tangent or cotangent would be x over y. So if this is the unit circle, we'll start out with the easy ones. If this is the unit circle, what ordered pair is right here where my finger and my pencil are? What x is this? 1. And then the y value is 0. On the unit circle, the radius is 1, so from here to here is 1. On the unit circle, what's this ordered pair at the top? 0, 1. On the unit circle, what's this ordered pair? Good. And then on the unit circle, down here is 0, negative 1. Okay. So this is the unit circle. Now, every single r value, every single radius is 1 for this. But for the x and y, right here, x is 1 and y is 0. But when I go to this one, x or y, neither of them is going to be 1 or 0. Because x is going to be slightly shorter. Y is going to be up there. We'll talk about that in a moment. Okay? What I'm going to do is I'm going to go over, just on the back, let's write our triangles that we've been working on, which 45, 45, 90, and 30, 60, 90. With the 45, 45, 90, what are those 3 sides? What are the 2 sides that we normally call them, like numbers? What do we put there? 1 and 1. And then what do we call the hypotenuse? Radical 2. And then for the 30, 60, 90, which side is the 1? Which side is the 1? The opposite of 30. The smallest angle is going to determine the smallest side. They're opposite of each other. And then my hypotenuse is 2. And then radical 3 will be the longer leg. Now, I wanted to redraw these, but I want to put them on the unit circle. Can these triangles, well, here I'll draw my XY axis. Can these triangles, they're going to end up being the 3rd quadrant right now. Can these triangles, nope, 2nd quadrant, I lied. 2nd quadrant right now. Can these triangles be on the unit circle as is? No, not as is. What makes it a unit circle? Okay, well, I get a circle going on for you here. So there's part of a circle. I'm not going to draw the whole thing because it'll overlap, but there's part of the circle. Okay, now it's part of a circle. What makes these triangles on the unit circle? Why is this not on the unit circle? It is something to do with the radius. Why is this one not on the unit circle? Because my radius doesn't equal 1. How about this one? Doesn't equal 1. Let's start with the easier one. How do I make 2 become 1? We have to use a scalar, a dilation. We have to shrink it down. You said put it over 2, but like what operation is put it over? What? Division? Let's think of it a different way, because when we talk about scalars, normally we're talking about multiplication. So to put it over 2, what am I actually multiplying? Half. We're going to get half of each of these. Nope, that one doesn't write. Not bright enough. A different color. Here's a color. So if I divide one of the sides by 2, or if I scale it by half, I have to do it to all 3 sides. Oops, and I didn't do it correctly. There we go. Over 2. And what is 2 over 2 for my hypotenuse? It's now a 1. That's what you're trying to do, is make it a 1. So now I have a triangle that would be on the unit circle. Let's do the same thing to this triangle right here. What would I do to all 3 sides so that I can make it on the unit circle? Right now the radius is not 1. How do I make the radius 1? Paige, do you know?
Multiply by radical 2 over 2.
Yes. That was like, no. Yes, by I had to see it. I had to like take a second. She said multiply by radical 2 over 2. I didn't expect her answer to be so complicated. I would have said multiply by 1 over radical 2, but these are equivalent, so then, yeah, you just left me speechless for a moment. Okay, so yes, just for a moment. So we are going to multiply by radical 2 over 2, aka multiply by 1 over radical 2, aka dividing by radical 2. All of those kind of the same thing, but like her answer was way better than I expected. So if I multiply each side by radical 2 over 2, and then that will make this one 1 when I multiply by radical 2 over 2. That makes 2 over 2, which is 1. There we go. Okay. Now we have a triangle on the unit circle. So when I go to ask you questions like on the unit circle, I'm just going to draw a mirror image of this so I can talk about 30 degrees. On the unit circle, what is the sine of 30 degrees? Sine is, that was too mumbly. Sine is y. On the unit circle, what we put on the front is sine is just y. And cosine is x. So if I want to find something like the sine of 30 degrees, if I know this ordered pair, sine is y, cosine is x. It's bad. All I have to do is look at that ordered pair and say, oh, sine of 30 degrees, that's a half. That's the y value at this ordered pair. This is how you use the unit circle to find these answers. What is the cosine of 30 degrees? Radical 3 over 2. So from here, since sine is y and cosine is x, I can rewrite this ordered pair if I want as cosine theta, comma, sine theta. Because that's what x is and that's what y is on the unit circle. That only works on the unit circle. Just checking. Everybody knows, only on the unit circle. Otherwise, you need r involved. So, take a moment and we're going to look at our first quadrant. And what do you think this first line is? Nah, even better question. This is 0 degrees. How many radians is it? 0. This is also 360, sorry. This is also 360 degrees, and how many radians? 2 pi. Okay. Then we go to the first point, that first ordered pair. What degrees do you think that's going to be? That's 30, which is what radians? Pi over 6. And then what ordered pair is it? Well, I need to know the cosine of 30, and I need to know the sine of 30. What's the sine of 30? We just did it. We just did it on the other side. It's 1/2. The sine of 30 is 1/2. So if the sine of 30 is 1/2, the cosine is going to be radical 3 over 2 because the radical 3 is in the 30, 60, 90, so it's got to be there in one place. Okay, what's the next angle going to be? 45, which is what radian? Pi over 4. What is the sine of pi over 4? It's radical 2 over 2. And what's the cosine? Also radical 2 over 2. And then what's the third angle? 60. And what radian? Pi over 3. Now what's the cosine? The x value, what's the cosine? Oops. What is it? 1/2. And what's the sine? Remember, the cosine is the x and the sine is the y. So if I needed a triangle, which I didn't draw the triangle here, if I needed to draw that triangle, I can look at these two side lengths and see that the x is way smaller. So for 60 degrees, the x is way smaller. Let's do one more. What degrees is this one up here? 90. And radian? Pi over 2. What is the sine of 90? Sine is y. Sine is y. So 1. What's the cosine of 90 degrees? 0. See how fast I did that? Cosine is y and cosine is x. How about the tangent? What did you do to get undefined? You do 1 over 0, which is undefined, yeah. So, oh, sorry, I was off the screen a little bit. You're just using the ordered pairs. If you are finding answers using the unit circle, then you are using ordered pairs. If your favorite way of doing it is not the unit circle, if your favorite way is, well, I already have all these memorized, or if your favorite way is drawing those triangles and putting the 1, 2, radical 3 in every single time and doing y over r, that's fine too. I'm just giving you different ways of doing it. I know some of you were required to memorize this in the past. Okay? It doesn't matter which method to me that you use. You just have to get done with your quiz. And if you don't know your stuff, you won't get done. Now I'm going to show you a trick. It's the hand trick, the left hand trick. If anybody knows the left hand trick, I'm going to show you that as well. Maybe that'll help you with your values. It's kind of silly, but it works. Crazy that it works. So everybody take their left hand. I'll do it up here. I'll also write it down on the back of this paper. But your left hand is like the first quadrant, okay? And then the 5 fingers are 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Okay, so there's your 90 degree right there. And anytime you put down a finger, that is a comma. And that divides the cosine, which is the x, from the sine. Cosine, then sine, which is in order of the ordered pair. Okay? So what I do is I have my hand. Oh my gosh, that was a good hand, huh? So this is 0, this is 30, this is 45, 60, this is 90. When you put down a finger, let's put down 60 here. Okay. When you put down a finger, what you do is you do this, the finger becomes the comma. That's the ordered pair comma. Oh, I can go in a little bit. That's the ordered pair comma. And then you take the number of fingers and you square root them, and you put that over 2 for the x and the y. You're going to do that for the x and the y. Okay, so I have my example right here where I have put down my, what is this, pointer finger. So the number of fingers I have up here, the number of fingers I have up here is how many? Yell it out. How many fingers is this? Even if it's a thumb, it's a thumb. How many fingers / thumbs is this? 1. So I do, for my x, I do the square root of that number, 1 over 2. And then I put my comma where my finger down was. And then how many fingers do I have up after that? 3. That will be my y value. So I'll do square root of 3 over 2. Now I'm going to use some, like, I learned this a long time ago sense, where what is the square root of 1? So the ordered pair at 60 degrees is 1/2, comma, square root of 3 over 2. Look, didn't even have anything memorized. I got it from my fingers. That's the ordered pair. So if I know the ordered pair, then what's the cosine of 60 degrees? It's the x. And what's the sine of 60 degrees? Radical 3 over 2. Notice this does not give me tangent. None of this is giving me tangent. None of this is giving me tangent. Okay? This just is like a shortcut for sine and cosine. Let's do another finger. How about if I did my middle finger? Boink. I'm going to put it down. If I put down my middle finger, then what would the ordered pair be? This is going to be for 45 degrees. What would the ordered pair be? Radical 2 over 2, comma, radical 2 over 2. And so what's the cosine of 45? Radical 2 over 2. And what's the sine of 45? Radical 2 over 2. It works with your thumb and your pinky finger too. So if I want to do like my thumb, what degrees is my thumb? That's 90. So what ordered pair is at 90? How many are in front of the comma? This is my comma. How many in front of the comma? 0. And then we have square root of 4 over 2. But what is the square root of 4? So what's 2 over 2? 1. So it even works for that one, even though that's like a lot of work. It works for all of the fingers. So that's just the first quadrant, though. If I wanted to do the second quadrant, you would just have to reflect your hand in the y-axis. So it would go like this way. It's the same stuff, though. Like, we just have a reflection now. So for me, when I fill this out, I only know the first quadrant, or I would only use my fingers for the first quadrant. I would just go over here now, and what changes when I go the other direction? My x becomes negative. So for all of these, they, what's it called? Are symmetric, they like reflect, except the x's become negative. So my x's here are negative, 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 whatevers. This one's negative radical 3 over 2, 1/2. This one's negative radical 2 over 2, radical 2 over 2. This one's negative a half, radical 3 over 2 when we reflect it. Same thing when we go to the third, it goes from being here to going down. It just reflects, and what becomes positive or negative when we go down? X is negative and Y is negative. And then for the fourth one, we can just reflect the first quadrant, and we go from Y's being positive to Y's being negative down here. So that's the only difference between quadrants. These little positive negatives at the top, if you want to fill those out, those just mean like sine, cosine, tangent. And then when I talk about sine, cosine, and tangent, if I talk about the cosecant, cosecant is just flipping over the y, reciprocating the y. Does that change negative or positive when I reciprocate? It does not change negative or positive, so I don't even write all 6 of them. I just know the first 3 are there, so the second 3 are there also. And then negative would be none. So that's just a place for you to say which are positive, which are negative, in which quadrant. Okay. I wanted to go over this because we're going to do a worksheet today to start. That's review over the things you've been doing. And you're supposed to use the unit circle. You do not have to use the unit circle. You can do it the old way if you want. I just wanted to give you this just in case you like using this finger trick, finding your ordered pairs, and then finding sine and cosine from that. Okay, and then after that, I'm just on the recording still. After we work on that worksheet, then I have a quiz review. For our quiz is Friday. And our quiz on Friday, we have a little extra time since we're lunch, but it should be short enough that you could do it in the regular like class time without the study hall. Or did they cut the study hall tomorrow? Did they cut the study hall? I'll have to look. But anyway, it should be short enough that if you were in any of my other bells, you could get it done also. Okay? Unless you don't know your values. Then you won't get it done. So you got to know your values. This worksheet that I'm handing you is non-calculator.